Hi there. Now we're going to do a high-level overview of Python. So we're not getting into the coding yet. This is not the syntax. Rather, I want to talk a little bit about the tools that you use when you engage with Python. So what do you get when you first install Python? That is, what is Python fresh out of the box? The first thing and most important thing that you get is the Python interpreter. And that is a program that, well, it's the heart of Python. It takes the code that you've written and it interprets or executes all of the commands in that code. So if it's a numerical computation, it executes that computation. If it's print something to the screen or print a plot, whatever it may be. So the easiest way to interact with the interpreter is to launch a so-called interactive session, also known as the standard Python REPL. And you can do that by opening your command prompt or terminal or PowerShell in Windows, and then simply typing Python or maybe Python 3. One of these two should work. And that launches the interactive shell or the interactive session. And I can use this to do anything. But for example, I could, if I wanted to know what is 8,473 divided by 75, there it is. 635 plus 53, there it is. So I like to use this interactive session or the standard REPL to do quick things with Python. So to use it as a calculator, fire it up, do my calculation, and then thank you very much. I'm going on to the next thing. So when you load it for the first time, or when you load the Python interpreter, what it knows how to do is known as the built-in functionality. And that includes these sorts of basic arithmetic operations, and then other stuff. Okay, so here is a list of all of the functions that are available when you launch the interpreter. So all of the built-in functions. And as you see, it's a lot of them. This is something I just screenshotted from the documentation, and it is in alphabetical order, so maybe not so useful. But here I have grouped all of the particular functions that we will use into 5 categories. So type conversions, type checking, summaries, used in iteration, and input-output. We're not going to go into the details of these just yet, but have this handy for when we do go into these. You can come back and notice, oh, this is a type conversion or type checking, etc. And it's good to just keep in mind what are built-in functions versus functions that you import. And I'm going to talk about importing now. So, okay, built-in functionality. That is not going to include everything that you could possibly want when you are coding. So if you want to add functionality, you do that by importing a package. So let's go to here, this slide. A Python package is essentially a folder that contains other Python files. So in this case, I have a folder called my package, and it contains files module a.py, another module.py, and a really amazing one.py, and maybe some other stuff. And these different Python files maybe know how to work together in order to provide some package functionality. And you will probably, for any given package, not need to know much about the internal organization of the package. You'll just need to know how to use it from the outside. So this package level interface. Okay, so back here, when you in order to add a package to your workspace, that is to extend beyond the built-in functionality, we use the import keyword. And I will talk more about the import keyword later, but you'll see it here and there. Python includes, out of the box, a large collection of packages known as the standard library. So let's have a look at the documentation for the standard library. If we go back to the Python page here, we go to documentation, Python docs. Here we have a link to the library reference. And this is the documentation for the standard library. We can see that, these are all links to different packages, and you can see that there are quite a few. Very many packages in the standard library. It's pretty big. And turns out that we're not going to use it much because we will tend to use third-party packages. But let's just see what's in here. So we have, it starts off with a bunch of built-in stuff. So these are things that are built in. You don't have to import them. Then here we get to documentation for individual packages. So this is the string package, the RE package, regular expressions, difflib package, etc., and all of these come under the topic of text processing services. We also have binary data services, additional data types. So for example, date time for working with dates and times. And zone info, so time zone, calendars, and other data types that we won't get into very much. Then we have packages for numerical computations. And Python comes with a math package that includes simple, say, trigonometric functions, sine, cosine, tangent, etc. Also exponential, logarithmic functions, and constants such as pi or Euler's constant. We won't actually use this much because it's superseded by NumPy, which is a third-party package, and we will tend to work with NumPy. There's also a package for complex math, a package for random number generation, and this one is quite important if you're doing anything with random numbers. Many packages for functional programming, for working with your file system. So this one we will learn, pathlib, gives you the ability to reference files in your file system. Data persistence means saving your data to a file. So Pickle is a package for saving data as a binary file. But you can also work with a compressed files, zip files, or other file formats, CSV, text files. Cryptographic services such as hashing a data structure. This we will not use. Then working with operating system. If you wanted to write concurrent multi-threaded applications, working over a network, sending data over the internet, email, JSON, or structured data, XML, HTML, different internet protocols, all things that we are not going to cover. Multimedia services, so audio files, for example. Internationalization. This is a nice one that I actually tend to use, tkinter. So this is for making simple user interfaces. If you have created a program and you would like to create an interface with a window and some buttons and pull-down menus and text boxes, a user interface, for your program, you can use tkinter, and it's part of the Python standard library. So, as you can see, there are many, many things in this standard library. Now, of course, it won't include everything that you could possibly want, and so Python, out of the box, provides a package management system with two programs. One is called pip, and the other is venv. we will learn these at the end of the course, but for now I just want to describe what pip is about. So pip is a program that allows you to communicate with the Python package index. So what is that? Let's go back here to the website. And if you go up here, you see there's a link to PyPy. That's the Python package index. And this is a repository where the Python community keeps all of the public packages, things that people want to share. And you can see that right now there are about 500,000 projects or packages in the Python package index. These include, for example, NumPy, which I mentioned is there. Well, if you wrote your own package, you could publish it in the Python package index. But let's say you are working with, say, finite element method, and you want to find a package that will suit your needs. Finite element method. I'm going to search for it. And here are a large number of packages that implement different aspects of the finite element method. Let's say that your friend has recommended FemPy 0.3.1. You click on that, takes you to a page that describes this package. And here at the top, you can see that there is a command that is the pip command for installing that package on your computer. So using pip, you can retrieve a package from the package index. That's just a simple command on your computer, and it will install it on your computer. We will describe that and how to do this more in detail later in the course. Now, what are the packages that we will use in this course, and also that are typical for engineering applications? First of all, NumPy. NumPy is, as I said, the most fundamental package for numerical computations. So everything that has to do with numerical computations, such as, for example, this finite element package, I'm sure, is built upon NumPy. NumPy provides a single type, which is called the NumPy array, and this does numerical computations very, very efficiently. Then we will also use, for plotting, we'll use Matplotlib. Matplotlib is, I'd say, the simplest of the plotting packages. There, of course, there are many, many that you can choose from. Matplotlib is based in MATLAB syntax. So if you're coming from MATLAB, you'll find this very familiar. It happens to be the only plotting package that I ever use. So it really does the job quite well. Then Pandas is a package that you can use for operating with tabular data. So if you have a table and each column has, say, one has names of places and then the other one has population of places, this sort of data structure, Pandas is very good for. So we'll learn Pandas a little bit. All right, well, the next thing that you really need to know is that in Python, there are two types of files, the module and the Jupyter Notebook. So a module is a file with a .py extension, and it is a plain text file with Python code. That's all it is. So it's a plain text file, means that you can open it in any text editor like Notepad or TextEdit or any other. A Jupyter Notebook, on the other hand, contains not only the code, but it has many other elements. So you can see here that this one has some markdown with titles and explanations, and there's some equations in there, and you can include plots from the code. You can also include figures and hyperlinks and tables. So it's a very rich format that is very useful for, say, doing a presentation, writing a report, or exercises. So the exercises for SDSE, Statistics and Data Science for Engineers, the labs are all in Jupyter Notebooks. So that is what we will mostly be using in that course. We will get to modules later in the course, and we'll talk about the specifics of that. But it's good to understand that even though Jupyter Notebooks are so useful, most of the code that's out there is in the form of modules, just because they're much more lightweight, whereas a Jupyter Notebook is really useful when you are presenting the code to somebody else. Well, I said at the beginning that the interpreter that comes, that is the heart of Python, you need a way of interacting with it. And the simplest way is with this Python standard REPL or an interactive session, which you do through your terminal. The downside to that is that if you close down the terminal or you stop the session, all of the code gets lost. So if you're writing any amount of code, you're going to want to put it into a file. And if you're working with a module, a .py file, putting it into a plain text editor is just fine. So Notepad text edit, you just save it as .py. There are some advanced text editors like Sublime or Atom that you can install a Python plugin into, and it gives it some additional functionality like highlighting keywords and so forth. Then there are also browser-based IDEs. IDE stands for Integrated Development Environment. So that connotes that there is additional functionality to this. Jupyter Lab is an online or browser-based IDE, and it's the one that we will use mostly for exercises involving Jupyter Notebooks. So Jupyter Lab is for Jupyter Notebooks. There's also, I think it's worth mentioning, Google Colab, which is a Google product. So just like, say, Google Sheets or Google Docs, if you have a notebook in your Google Drive and you double click on it, it's going to open Colab. And Colab is where you can edit and execute these Jupyter Notebooks that are in your Google Drive. Nice thing about that is that you are using Google hardware, cloud-based hardware, and they allow you to, say, use advanced hardware, GPUs and so forth, and you can pay some money if you need additional compute power that you don't have on your machine. So that's a nice resource. But what I would really recommend is that you learn one of the advanced IDEs. This is where you're probably going to end up. An advanced IDE is what I'm calling a program that you install on your computer, and it has all of the functionality that you'd be used to if you're coming, say, from MATLAB, that has a very nice IDE, or RStudio, something like that, where you can have breakpoints, you can debug, you can step through the code, you can track the value of different variables, and so forth. So there are lots of functionality there, and that's really sort of the power user way of writing Python code. So eventually you'll get to an advanced IDE. I recommend that you start as soon as you can, as you feel comfortable. We'll be using VS Code, and I'll try to make a video where I show how to set up VS Code in a different video. Okay, that's it for the high-level description of Python. I'll see you in the next video. Bye-bye.